And welcome to the video lecture on relations/tables. Because for all intents and purposes, when we talk about relations as being tables. So a relation, right, again, table, is two-dimensional data, right? So you can, you're probably most familiar with Microsoft Excel. So if you think of an Excel spreadsheet, is quite often a two-dimensional table of data if you simply have a list of data. The table, all right, when we refer to a table or, again, a relation, consists of rows, otherwise known as records, and columns, which are attributes or fields. So that we're just throwing a bunch of terms in here. A lot of them are interchangeable, so you'll hear me talk about rows. If I say rows, that's also the same thing as saying records. When I talk about columns, I'm also talking about attributes and fields. When I talk about a relation, I'm also talking about a table. So kind of keep that in mind. I'm going to try to be consistent. I'm really going to, from this point forward, going to try to stick with table, records, and fields. Because really from this point forward, when we get to the physical model, the physical model definitions are really going to be table, records, and fields. So I'm gonna try to do that. We'll see how that works out. The requirements for a table to qualify as what's known as a relation. First of all, it has to have a unique name, which makes perfect sense. That goes back to other rules that we talked about naming conventions and data definitions in previous chapters. Every attribute must be atomic, right? So not multi-valued, not composite. So even though we've been going through setting up the ER diagram, some of the ER diagrams that we've set up have had, or that we've had in examples, probably not in the databases in your project, but some of them that we've talked about are multi-valued or are composite. When we get to a relation, when we're actually defining a relation, again, this is moving towards the logical database design, all of the attributes have to be atomic. So really think about if you have any attribute that is, say, a comma delimited list of some kind, that is otherwise known as multi-valued or composite. We're going to have to break that down, or break those down into atomic attributes. Every row must be unique to every other row. And again, it's pointless to have two rows or records with the same exact values for all of their fields. What's the point? That's just a waste of space. Attributes or columns, or in this case, I'm really going to talk about fields, in tables must have unique names. In other words, it would be pointless to have two attributes in an entity that both say name. Right? Maybe you make one F name, one L name, but it would be pointless to have them both as names. The order of the columns must be irrelevant. We're going to talk about an example of that later. But if you think about it, when you think about Excel, I don't know if any of you have ever experienced this because Excel is better at this now, but there's a possibility that you can set up an Excel spreadsheet, do a sort, and all of the data from a particular column will be sorted, but the rest of the data will stay in its place, and then all of your data gets destroyed. So in this case, the way databases are set up is all records move. You can't move data in fields independently of the records. So the order of the columns has to be irrelevant. Well, the order of the rows must be irrelevant. The order of the columns must be irrelevant as well, and that's the order of the attributes, which really should make no difference. So, if a table meets all of those criteria, that's what's known as first normal form, and we're going to talk about normal forms in another video. Now, let's just talk about how the tables or relations correspond with the ER model. So a table, once you have an entity type, that entity type more than likely is going to get converted into a relation/table. The rows will correspond with entity instances. and with many-to-many relationship instances. We'll talk about that when we talk about associative entities. And columns correspond to attributes, columns, and or we're going to refer to as fields. So the word relation is not the same as relationship. So that's just a note, right? So, when you're talking about relations are tables / entities. They have nothing to do with relationships. All right, so that is the end of my video associated with relations / tables, and we're going to move on from there.